It is one of the greatest tragedies of modern times. A quake so powerful, it knocks the Earth off its axis. A tsunami leaves tens of thousands feared dead. Parts of Japan shift 10 feet out to sea. Parts of the coast drop over 3 feet. What forces create this epic disaster? Now, a team of scientists is looking for answers.
Never before have we had such a surplus of data. There are no mysteries in this earthquake. We know exactly what happened.
Japan's coast lies in ruins. Incredibly, it could have been worse. Scientists' understanding of earthquakes and tsunamis saved lives. But as this disaster shows, there is much more to learn. Japan's killer quake, right?
The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And by the Corporation for Public Broadcasting. And by contributions to your PBS station from viewers like you. Thank you. Additional funding is provided by Millicent Bell through the Millicent and Eugene Bell Foundation.
It is 96 hours since Japan's largest earthquake in 1,000 years strikes. Professor Roger Billum from the University of Colorado is one of the first geologists to survey the aftermath.
So we're flying right over the coast right now, and much of the coast has sunk about a meter. The extent of the damage is truly amazing. The tsunami picked up everything in its path, cars, houses, warehouses, and just tumbled them relentlessly inland, on and on and on. One of the things I'd like to see is exactly how far it went, what kind of debris gets left behind on these gigantic tsunamis.
Every detail of the disaster is recorded by seismometers, strain gauges, and tidal gauges. Now Billum looks to piece it all together to find out exactly what happened and why so many lives have changed forever. How did this happen? March 11th, 2011, 2:46 p.m. Japanese time. 60 miles off the northeast coast, a massive earthquake. Seismic waves race towards shore. The fastest waves, called P waves, travel at 4 miles a second. 15 seconds later, they hit land. Japan's detection systems instantly pick them up. Within seconds, automatic warnings flash across the country. A computer-generated announcement interrupts a Japanese parliament broadcast. The coastal city of Sendai lies just 80 miles from the epicenter. There's almost no warning before slower, more destructive seismic waves called S waves hit the town. These slower S waves violently shake the ground from side to side. These are the waves that make earthquakes so damaging. Already, Northeast Japan is descending into chaos. The seismic waves travel on. 93 miles southwest of the epicenter, they slam into Fukushima Daiichi, home to an aging nuclear power station housing 6 reactors. This video from a hospital near the reactor reveals the earthquake's power. Sensors at the plant automatically shut down the reactor cores. The reactors are in lockdown when the S waves hit, but the intense heat generated from the nuclear reaction process does not simply dissipate.
When you think shutdown, you think, the danger's gone because it's shut down. But the reactor core was still extremely hot. You know, if you have a pan in the oven and you shut the oven off, that oven continues to heat inside even after you've turned it off.
With the reactors stopped, there's no power to drive the cooling pumps. The reactor cores heat up. Emergency diesel generators take over, pumping coolant through the reactor. The Fukushima plant survives the earthquake intact. Scientists 3,800 miles away at the Pacific Tsunami Warning Center in Hawaii receive emergency alerts. Researchers around the world see the event unfold.
Japan has lots of seismometers, so there was a lot of information fast. So the earthquake was still going on when we got our page.
First indications, a magnitude of around 7. But as data floods in, the numbers start to climb. 7.5, 7.7, up into the 8s.
The immediate reaction of everybody was, that's not right. Because in the history of Japan, there has never been an earthquake larger than 8.4.
Really heightened the intensity of what we were doing, because we knew we were dealing with something very big and something that could affect the whole Pacific Basin.
We realized, oh, this is it. And then immediately you realize, this is horrible for Japan.
The source of this disaster lies 62 miles off Japan's coast. 4 miles below the surface, the Earth is distorting, caught in a vast slow-motion collision. The Earth's crust is made up of several continent-sized slabs of rock, tectonic plates. Japan lies at the point where the Pacific Plate rams into the Eurasian Plate at 3 inches a year, about the same speed your fingernails grow. Japan is on the Eurasian Plate. It compresses and buckles as the Pacific Plate drives underneath it, snagging and catching as it goes. Over centuries, immense stress builds up until suddenly the plates snap, causing an earthquake.
The energy that drove this earthquake had been building up for a couple of 100 years. It's caused by the movement of the Pacific Plate towards the Eurasian Plate. Think of it as a giant elastic band that's being wound up for 200 years.
100 seconds since the fault line slipped, the destructive S waves reach Tokyo.
Tokyo 渋谷のスタジオが非常に大きく揺れています。東京の渋谷のスタジオが大きく揺れています。
The city has 60 seconds warning. The quake lasts an unprecedented 5 minutes. An American geologist is in Tokyo.
We expected it to end after 10, 15, 20 seconds, something like that, maybe a minute at the most. About minute 3 or 4, we were just all kind of astonished that it just kept going and going and going. just looking at each other going, is this over yet? And no, it's not. It's still going.
What is different about a big earthquake is that it begins, but it doesn't stop.
It was kind of a growing realization that it was just getting bigger and bigger and bigger, and it had to be fairly close.
An American tourist captures the ground opening up at his feet. The footage reveals a frequent characteristic of earthquakes: liquefaction.
Okay, we have earthquake right now, and this is actually moving. Can you see the cracks moving? That crack was not there. That crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now.
Loosely packed and waterlogged ground near the surface starts to behave like a liquid. As the ground compresses, liquefied dirt pumps to the surface. Most buildings still stand. Japan's earthquake warning systems work. Scientists upgrade this quake to a magnitude 9, 1,000 times more powerful than the devastating 2010 Haiti earthquake. But everyone in Japan knows this is far from over. The earthquake's explosive energy is about to unleash another destructive force. For centuries, the Eurasian plate is dragged downward by the Pacific plate grinding under it.
The whole upper plate behaves just basically like a rubber block. It just compresses, and like a spring like this. And when the earthquake happens, it springs back.
The upward motion thrusts a 4-mile-deep mass of water upwards. When the dome collapses back, immense waves race out across the ocean. Just 3 feet high and over 60 miles from front to back, the waves travel at a blistering speed. A tsunami is born.
The energy heaved up the sea floor. That displaced vast amount of water that we can see made its way on land, it made its way off around the Pacific.
One side of the wave takes off across the Pacific. The other races towards the coast of Japan.
Tsunamis travel very fast at a speed that depends on the water depth. And because in the deep ocean, tsunami travels very fast, reaching at times the speed of a jet aircraft.
Traveling at over 500 miles per hour, the wave takes just minutes to reach the coast. Here, the shallower seafloor slows down the front of the wave. The wave's fast-moving rear races in. It soon catches up with the front. The increasing pressure pushes the seawater up into a rising swell. 3 miles from shore, a Japanese Coast Guard crew witnesses the growing wave. The tsunami swells up as the seafloor gets shallower. Once they crest the first wave, a second one is upon them. The crew is lucky to survive. Near the coast, the swell becomes a breaking wave. It piles up. A wall of water races toward shore.
The very first thing that seems to have happened is that the sea left the land, and some of the footage we've seen shows a huge shoreline being exposed, and then the tsunami built up offshore, and the dynamics of the wave carried it inland. Probably a cubic kilometer of water just splashed landward and kept going until it ran out of steam.
This is the moment the first wave roars in. The tsunami has arrived. But there appears to be no clear pattern to when or where the tsunami strikes. First, it hits in the north. Then in the south. Then it strikes in the north again. The height and intensity of the wave varies dramatically from town to town. But why? Part of the answer lies in the varying depths of the seabed. The tsunami travels faster in deep water and reaches land more quickly. Another critical factor is the layout of the land. Cliffs, bays, and inlets along the shoreline help determine how a tsunami behaves.
It boils down to how the wave is focused and defocused by the geography or the topography of the coastline itself.
3:15 p.m. Japan time. The wave hits the town of Ofunado. Deep water off the coast here offers little resistance to the 26-foot-high tsunami wave. There is little time to get to high ground.
The best early warning system people would have had would have been the fact that there was an earthquake. And people have got used to the fact that if you have an earthquake, there is a possibility of a tsunami that will follow. But in the timescale they had, there was very little time or very little opportunity for escape.
The tsunami hits Ofunado 20 minutes after the earthquake.
Water that actually hit the coast will be well in excess of 1 billion, probably 10 billion tons of water. That's a little bit like taking 1 million swimming pools and just emptying them onto the coastal areas of northeast Japan.
"15 minutes.
It hits very low-lying areas. There's nothing to stop it moving inland. And so it can move inland 6-7 kilometers without being impeded.
There's not much to slow it down, and because the wavelength of the tsunami is so big, it's not going to stop until it reaches something, reaches some sort of high ground, and it'll just keep on coming.
Next, the wave slams the Miyako coast, 110 miles north of Sendai. This area has good tsunami defenses. The residents are well prepared. They should be safe. Last time a tsunami hit here was half a century ago. In the aftermath of that tsunami, they built these 30-foot-high seawalls. Tsunami drills are a regular feature of life. Everyone knows what to do when the sirens sound.
Tsunami, yeah, we're leaving. Where do we go? Go to the hill.
On March 11th, the sirens sound. The tsunami is minutes away.
You hear the sirens?
There's a hill outside of town that we're going to try to get to.
Confusion rules. Some search for high ground. Some aren't sure what to do.
Well, it's a precautionary measure, but I mean, you know, you never know. This town has a lot of history with tsunamis and a lot of death from it, so they're taking it pretty seriously, obviously.
The warning saves the lives of some.
Here it comes!
The tsunami easily breaches the coastal defenses. Miyako's high walls are useless. The tsunami is 30 feet high. So why did the 30-foot-high walls fail? Data from thousands of sensors along the coastline suggest a stunning answer.
The fact that the shoreline has actually subsided means that the sea had plenty of space to go, and it basically filled up the empty space left by the sinking. Several villages have just been completely ruined with no survivors, and the human death toll is obviously going to be up in the tens of thousands when the final count is in.
The earthquake causes the whole coastline to drop by up to 3 feet, lowering Miyako's walls and making the tsunami much worse. All along the coast, this sudden drop in the height of the land puts towns in danger.
You've got the tsunami wave coming in, on top of what would be essentially a 2-meter higher vacuum of subsided land as it sweeps in, and there's not much to stop it until it hits higher ground somewhere.
Fukushima's shut-down nuclear power plant is exposed. There is an 18-foot-high defense wall, but the ground has sunk several feet. The wave smashes over the wall and floods the diesel generators cooling the reactor cores.
Japan, as part of its normal defenses against tsunamis, has along its shoreline a tsunami wall, and this wave of water was several times that height and just blew right past it.
If the coastline goes down, so do all their power intakes, and if they have a gigantic wave coming at them, it's going to short out everything electrical.
Backup batteries take over to keep the pumps going. Batteries with just an 8-hour charge. The tsunami's destructive march inland overwhelms seawalls, erases whole towns, and sets Japan on the path to a nuclear crisis. And it isn't over yet. Now, all that water pulls back out to sea.
huge suction as the wave retreats and drags the debris it's created on the way in, the cars, the lorries, the buses, the trains, the buildings, the people. And so they're sucked back out into the ocean.
From miles offshore, the ocean is a churning mass of currents. Huge whirlpools form. Boats like this are no match for its power.
Sadly, I think many thousands of people would have been dragged out to sea. And I suspect, tragically, we're going to find bodies washing up along the coast of Japan for some months to come.
During the night, fires rage across the wasteland. Oil from factories and natural gas from ruptured lines set hundreds of square miles of debris on fire. In Tokyo, the train system is paralyzed. Millions sleep in offices and wait for dawn. 8 hours after the quake, the tsunami wave continues to spread across the ocean. Countries all around the Pacific Rim watch nervously. In Hawaii, the Tsunami Warning Center is on full alert.
Very quickly, we realized that this was basically the first big ocean-crossing tsunami that had happened in 40 years.
Will the tsunami hit Hawaii? If so, when? And how big will it be? Readings from deep ocean sensors suggest the wave is up to 3 feet high.
Now that is monstrous on the deep ocean for a tsunami to be that big. And at that point, we went to a Pacific-wide warning, which means another message, and now lots and lots of phone calls.
State warning point. This is the Pacific Tsunami Warning Center.
Hawaii issues an evacuation alert. People head for higher ground. The wave hits Hawaii. As predicted, it's 3 feet high. For more than an hour, it surges over the islands.
Whoa! Gosh, that is big. That is absolutely massive. Just lost my shoes. This is coming straight over the wall onto the main road. That is absolutely unbelievable. Here it comes again. Pouring over the wall. You can see a car making a run for it out there. I am completely stranded now between the wall and the road.
There is tens of millions of dollars in damage. The wave pulls cars and houses out to sea. Hawaii's early warning system gives people time to get away from the coast. Here, unlike Japan, no one loses their life.
So the warning system works incredibly well. But obviously, if the event happens literally on your back doorstep, then no warning system that could ever be conceived could be quick enough.
Tsunamis are simply unstoppable, but they can be tracked. The Hawaii Warning Team monitors the Japan tsunami across the Pacific.
We couldn't let our guard down because, of course, the tsunami has continued on, and we have a continuing responsibility to the rest of the Pacific.
The scientists effectively warn the world.
As the tsunami spread across the ocean, at location after location, we realized, our predictions are pretty darn good.
Japan's tsunami surges toward the U.S., its power diminishing with every passing mile.
There's a very intensive wave, but as it spreads out, that energy is being distributed along a bigger and bigger circumference.
10 hours later and over 5,000 miles from the quake, the tsunami, now smaller and weaker, finally hits California. The wave still creates havoc along the coast.
There, certain parts of the coast focused the wave. So although it was only 1 meter in Hawaii, it actually became 2 meters in places like Crescent City in California. And again, because people were warned, there was very little destruction or damage, certainly to human life. One person did lose their life in California, north of Crescent Bay, because they rushed down to the beach to take photos of the tsunami as it came in.
Back in Japan, the crisis continues to escalate. Different locations suffer different effects. Veteran journalist Callum McRae sets off along the coast to discover how far-reaching the tsunami's damage is. This is the isolated mountain community of Kahoku.
We're up in the mountains, 8 kilometers from the coast. And what's happened here is that the tsunami has created a huge surge which has climbed all the way up the river and then flooded here.
The result is stunning. A new saltwater lake among mountains, miles from the sea.
この裏にね、川があるんですよ。排水堀ってね。それで、通常はね、ほとんど水がないくらいなんですよ。通常は。ところが、津波もね、1波目は来なかったんだけど、2波目あたりからやっぱり登り始めて、ね、夜のうちに登ったんだね。そして夜のうちに登ってきてね、知らないてるうちにもうここに水に乗っていたわけです。次の日からね。それからずっと引かないでそのままなってんだね。もう私たちも先代からここに住んでいないともうないの。私だけでも70年なんだけど、こういうこと初めて。70年以上なんだけどね。初めてだね。
The locals here fear the receding waters will expose bodies swept up from the coast. Traveling north, McRae reaches Ofanato. At first, the town seems untouched.
Look over there. Those houses look undamaged. They've got power and everything here. That's just so strange.
Closer to shore, it is a different story.
And as if Ofanato didn't have enough problems, scientists reckon that this whole area, this region, has subsided well over a meter. And in the next couple of days, the region is also expecting the highest tides of the year. The sea is some 500 meters down there, and yet up here we have this. It's a remarkable sight by any standards, a huge tug which has been brought all the way up here by the tsunami. And what's remarkable about it, or what's even more remarkable about it, is that what it says about the size of the tsunami. Because the Japan Meteorological Center have just produced provisional estimates saying that the tsunami that hit this region was about 3.5 meters high. Now we're 7-8 meters above sea level here, and even given the surge, the fact that it could bring that all the way up here does suggest that the tsunami here was a lot higher than 3.5 meters.
Boats, trucks, and cars are dumped on top of buildings, much higher than the recorded height of the wave.
That happens because as the water's pushing through restricted areas like the streets of towns and villages, it's being effectively funneled. And the water's got to go somewhere, And so it goes up as it's squeezed and funneled and pushes material, pushes cars onto roofs, sometimes as high as 50 feet. So in areas, the impact of this will be even greater, particularly where you get narrow streets.
Once the wave starts to pick up part of a town, the warehouses along the dock, the debris and all that, then it becomes more like a glacier. You know, it's a moving wall of debris. And the more mass it has, the more power it has as it comes in. It doesn't really look like water beyond some point. It looks like the entire town is flowing in, and it is. So all the mass of all the buildings, cars, refrigerators, and everything that's in that wall, it's essentially a debris glacier at that point, and it just keeps coming in.
This is Minami Sanriku, a town that has been virtually wiped off the map. 95% of the buildings destroyed. Over 10,000 people, half the population, missing.
This place symbolizes the tragedy more than anywhere. An entire town wiped out by the force of nature.
It's almost difficult to imagine one's thoughts as one sees this coming towards you. And as it hits the coast, it's then picking up all the debris, it's picking up buildings, cars and things, and you then end up with this sort of really quite horrific mass moving through towns, villages, across fields, causing complete destruction.
I mean, it would be bad enough if it was only water, but because it's full of cars and you can't swim against it or flow with it or do anything, you're just like in front of a bulldozer of moving the entire town.
It's funny that when you hear that sound of an ambulance, it kind of actually gives you hope that they might have found somebody alive. Although that must be happening fewer and fewer times between. Anyone who did survive and was trapped would almost certainly have died of hypothermia by now.
At the town of Rikuzen Takata, 25 miles up the coast, rescue workers hunt for survivors and discover the dead.
When they find a body, they put a large stick in the ground with a flag attached to it so that it can be recovered later. It's a fairly gruesome and sad task. In fact, they're not just collecting bodies, they're also collecting personal mementos as well, which they find, like this. I'm afraid what we have here is more bodies waiting to be taken away.
Within days, scientists gather more data from Japan's earthquake and tsunami than from any other disaster in history. Over Tokyo, Professor Roger Billam returns from his aerial survey. The city's vulnerability is clear.
There are 30 million people within about 2 meters of sea level, and a tsunami here, of course, would be absolutely devastating.
Suddenly, there is a problem.
We had a big earthquake just now, so...
Really?
Yeah.
We've just learned from the ground that there was an earthquake that damaged the heliport. They're checking for damage right now. We don't know how big the earthquake was, but it was obviously a very nearby aftershock.
A massive aftershock hits Tokyo, magnitude 6.2. In the week that follows the main quake, there are over 500 aftershocks. This is the actual data from seismometers around Japan. The larger the circle, the bigger the aftershock.
The shaking is now stopped, so I'll just continue landing.
Finally, Bilham's helicopter receives the all-clear to land. The helipad is damaged.
I've noticed that the tarmac here, which should be beautifully dark everywhere, in fact stained white in places, and you can see that in fact sand has come out of this crack, and there's another one over there, another one over there. We're very close to the shoreline, and the lurching motion of the ground during the earthquake has caused the subsurface liquefied sands to come belching out on the top.
Here there is evidence of liquefaction, the strange phenomenon filmed earlier.
And over here is an old mud volcano. Old, it's about 3 days old. You can see how the mud came pouring out of the top there. So look, we're 200 miles from the epicenter here, and here's a crack in the heliport landing area. It continues all the way along here. You can actually see down about 3 feet in places. Splits into two here. This goes over here. You can see an offset in the in this trim around the tarmac.
As the Earth's crust shatters during the main quake, new stresses spread along the fault. Relieve the pressure in one place, and it builds up somewhere else, triggering aftershocks.
What you're seeing here is how those aftershocks happened over a period of about a week after the main shock. And that orange region, delineated by those orange dots, essentially gives you a feeling for the area of the fault along the plate boundary that ruptured in this event.
Every aftershock takes its toll on an already frightened population. And every aftershock potentially triggers another one.
That main shock was followed by hundreds of magnitude 5s and dozens of magnitude 6 earthquakes and a handful of magnitude 7s. Once you had a pattern of an earthquake happening, followed by a bigger one, you never know whether it's going to happen again.
Unrelenting tremors are just one of the new realities facing the Japanese people. Hundreds of thousands are homeless. In the regional capital of Sendai, the temporary shelters are full. But in this darkened, ravaged city, people do their best.
We're in Sendai, 300 or 400 meters from the shorefront, in a scene of apocalyptic chaos. It's cold, it's dark, there's no power anywhere. And yet, up there, in that abandoned block of flats, on the top floor, there's one light. One man, one family perhaps, trying to survive in this chaos.
The following day, on the main road back to Tokyo, the artery that connects north and south is empty. A reminder that this country has ground to a halt.
This is already one of the worst nuclear accidents in history if it stops right now. And we're dealing with multiple meltdown possibilities.
2 radioactive substances, cesium and iodine, were detected near the #1 reactor at the plant on Saturday.
The Fukushima nuclear base is about 60 kilometers that way. That's about 38 miles or so, I think. You know, we've got the windows closed. We're driving fast. Who knows whether it's safe? The advice is very conflicting. The American government says that has put an exclusion zone of 80 kilometers. And of course, we're well within that. On the other hand, the Japanese government say it's fine as long as you're more than 30 kilometers away. So, I mean, you can tell, nobody knows. but we'll keep the windows closed and I'll put on a mask. Mask. Looks good, huh?
At Fukushima power plant, the nuclear crisis worsens. The emergency batteries are dead. There is no power to cool the reactors. Temperatures quickly rise. Water levels drop. Pressure builds. The incredible heat of the fuel rods generates hydrogen gas. The hydrogen explodes. Desperate plant workers inject seawater into the reactors in an effort to cool them.
Essentially, those plant operators at the time said, we're going to commit plant suicide. We're going to go ahead and kill these plants, knowing that they'll never work again. But that was a better option than not letting the cooling system fail and risking even a worse outcome.
There's been another blast at a stricken Japanese nuclear power plant, the second hydrogen explosion in 3 days.
The Japanese military use helicopters to scoop up seawater to dump on the reactors. It doesn't work. The long-term consequence of what is happening at Fukushima remains unknown. The humanitarian disaster continues. Estimates put the death toll from the quake and tsunami at over 20,000. For scientists, the analysis goes on. From all the data they have acquired, one threat is still very real. For years, experts have warned of a large quake and tsunami off the coast near Tokyo. Japan's recent disaster happens 260 miles north. But now, the fault lines below Tokyo are even more stressed.
What's been expected is slip of the Philippine plate relative to the Eurasian plate. And what has actually occurred is slip of the Pacific plate relative to the Eurasian plate. Sometimes a great earthquake will cause the next patch of the plate boundary to slip. So all eyes are on what's happening, how this earthquake has stressed the neighboring part of the plate boundary. You've got to understand this whole region is in a very high state of stress and it's ready to go. And they've been expected to go any minute. So this recent earthquake is going to have brought that closer. The question is how much closer?
When an earthquake like this happens, it basically, all of the stress that it relieves in the Earth's crust essentially gets transferred somewhere else. It doesn't go away. It actually adds loading to other parts of the crust.
The densest areas of population survive largely unscathed. Next time could be different.
One area of extreme concern is Tokyo, the world's largest city. There could be a major event in Tokyo that would be extremely damaging to this very densely populated region.
If you were going to choose somewhere to put one of the major industrial economies on the planet, that part of the Pacific Rim is not the place you would choose.
It could be happening as we speak, or it might not happen for a decade.
The critical thing is, has this particular earthquake shaken that region up so that it brings forward the timing of that earthquake?
It's foolish to think that we can stop natural phenomena. What we've got to do is to learn to live with them and minimize the consequences when they happen and minimize also the recovery time.
It's very difficult for science to protect against earthquakes and tsunamis. What science can do is help town planners, engineers to make buildings stronger, to make designs of buildings and cities more resilient. We cannot stop these things happening. We can't prevent it. We can prepare for it.
Scientists believe Japan's tsunami holds valuable lessons for the U.S.
One of the interesting things about this earthquake is that it's really a template for what might occur on the northern coast of Oregon and Washington. We know we are expecting an almost identical sized earthquake.
Stretching from Vancouver Island to Northern California is Cascadia, a vast and volatile fault line. Here, like Japan, one plate is driving beneath another, squeezing and compressing it. tremendous pressure builds. Cascadia could rupture in a huge magnitude 9 quake. A megaquake off the Pacific Northwest coast would create a tsunami similar to Japan's. Roger Billam scans the coast of Japan for clues. He hopes to understand what could happen to America's west coast.
Like this coastline is long and flat. Parts of the Oregon coast are mountainous, that's not going to be a problem, but where we have flat-lying land near the shore, we've got to expect a similar effect.
It's a little bit like airplane crashes. The people go in and try to figure out what happened and learn from that. And unfortunately, we learn from these disasters, but it makes people stronger for the next one.
The world has seen what happened in Japan. The question is, are we prepared?
We compare it to Japan, where the preparation level is higher than what we have in the US. And we see that the Japanese had still quite a ways yet to go. It's a little sobering. Think about how many decades of work we have in front of us just to get to where the Japanese were, and then we have to get probably beyond that as well.
Major funding for NOVA is provided by the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And by the Corporation for Public Broadcasting. And by contributions to your PBS station from viewers like you. Thank you. Additional funding is provided by Millicent Bell through the Millicent and Eugene Bell Foundation.